Very good afternoon to all dear listeners and warm welcome to Pradeep Kalbar Saab. Very warm welcome and we are very thankful that today you joined and we are grateful also. Today I am not in my room. I have some meetings across Delhi. So I am in the visit. But anyhow, we have scheduled this online meet with our listener, our students, our doctors, many uh, who are working across India in water sector. Many professionals are also joining, and those who work at ground in water sector. Some are chief engineers, some are executive engineers, some are assistant engineers. They also joined our lectures. So it's a privilege and it's an honor to host you, Professor Saab. Uh, 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 that you allow us to host you. And over to you, Pradeep Saab. Just before that, I'll start. Pradeep Saab is a professor in IIT Mumbai, and he has great in-depth knowledge in this segment. And hopefully, sir, I'll request थोड़ा सा आप अपने बारे में भी बता दीजिएगा
Sure, sure.
बिकॉज थोड़ा सा मैं मोबाइल पे ज्वाइन किया हूँ
ठीक
एंड
है, ठीक है. No
तो
problem.
काइंडली थोड़ा सा हमारे
Sure.
लिसनर्स को अपने बारे में बता दीजिएगा एंड वंस आई विल फिनिश Mr. Naveen, one of our colleague, will also take over once Professor Saab will finish this lecture. And thank you, Professor Saab, for joining us. And over to you, Professor Saab. Please join and over to you.
Thank you, thank you. Thanks for taking this initiative. It's really good commitment that you have every Sunday you're hosting some talk, which is very useful for all the professionals. Yeah, so thank you. I will share my screen and I will start. Yeah. Hope my screen is visible.
Yes, sir. We can see your screen, sir.
Yes, thank you. Okay, so welcome all to this talk, which is mainly about circular economy of urban water for sustainable growth. Myself, Pradeep Kalbar. I am a professor at Environment Science and Department at IIT Bombay. I run a lab called SISTI Lab, which is basically looking at sustainable and resilient infrastructure, systems, habitats, and technological innovations. So basically, purpose of this particular talk is to give an overview of what we have done in circular economy sector, especially in water. So last talk, I guess Anuj has talked about my student who has talked about water supply sector, what innovations we have done, how we have addressed the ground issues. And that talk is already there in the group. So basically, our group works on the entire water cycle where all these things are studied. The second theme which I'm going to talk today is connected to wastewater management and circularity. So we look at various aspects of wastewater management, starting from sanitation challenges, appropriate technology selection, reuse and recycling challenges, techno-economic aspects. So all that happens in the used water management or wastewater or sewage, whatever terms you want to use. Today, focus will be this, okay? And how to quantify circular economy and all those discussions will be there. While we talk about water, it is very important to learn about sustainability and resilience because in today's time, whatever we are doing, it has to be sustainably, it has to be assessed by sustainability. So we work on life cycle assessment, material flow analysis, we work on resilience, climate change adaptation, mitigation, and some policy making. And we have such initiatives like Ajio Water, which is started by Dr. Anuj and I. We have started this. And Jal Vishwa tool today I will introduce, which is another initiative that we have. So overall, whatever happens in the sustainability circularity sector, our lab research team is third research team. So, coming to today's talk, which is circular economy of water, I acknowledge my two students, Dr. Nikita and Dr. Shweta, who have worked rigorously on this topic, and their PhD work I'm going to present. Whatever work I'm going to present, it is coming by working with them, and very fantastic work both of them have done. So basically coming to this topic, why this crisis is happening is about water urbanization. We have huge resource extraction, groundwater, surface water, freshwater demand is also increasing. There is a concerns about water security. India is projected to be mostly severely affected, and locally it will be so regionally, locally differences will be there. So there is a tremendous water stress, and our urban water cycle is in disturbance. So all this is leading to a water stress, and one of the ways to tackle these issues is following a path of circular economy. And that is one of the idea of this talk, that how circular economy thinking will be helpful for solving this problem. So those who are new to this circular economy term is very simple term, simple concept, that right now we are using linear flow, that all our resources, materials, nutrients, water, construction, building materials, anything that we are using is in linear way. While circular economy emphasizes that we should do in a circular way. Now saying is very simple, doing is very difficult. Okay, that we have to reduce the thickness of this arrow and increase the thickness of the circular arrow. So we have to transition towards circular economy. Now, while we do that, we have to remember that everything circular may not be sustainable. For example, in the enthusiasm, people may think I will connect my toilet to tap because technology is there. Okay, and I'll talk more about it. That technology may allow you to may circulate everything in one go, but that may not be prudent. That may not be required. That may not be wise for in the long term time. So we have to think how much level of circularity we have to apply at a particular place, at a particular location. So that is the introduction to circular economy. Now, coming to water management challenges. Water reality changes as per region and sector. You cannot define a particular problem that unique for all the sector, because even if sometimes you may say water is available. For example, I come from a region, Kolhapur region in Maharashtra. We have a huge amount of water available, but managing the sources and bringing it to the user is a challenge. Still, Kolhapur city has very some areas not getting water. Daily water supply is affected. So we may have a bulk water, but managing that water is very important. Each sector has its own challenge. Irrigation sector efficiencies are different, groundwater challenges are different, surface water challenges are different, use water management, recycle water management, and all are connected. What I see in many of the solutions is that people are working different in a isolated manner for irrigation, for groundwater, for urban water, but all are interconnected. And I will show how to think in a holistic manner for water management. We need a good operational infrastructure to abstract, treat, distribute, recollect, recycle, and overall manage the water cycle. Because if we do not have a good, see, infrastructure is there, whether it is operational is a big question. When I see numbers in many programs and mission, there is a lot of numbers are posted that these many STPs are there, these many pipelines are there, these many tanks are there. We see whether the operationality of those infrastructure is very important. Secondly, universal water supply and sanitation provisioning is a challenge. Okay, so because we have to provide water and sanitation for all, which is a huge challenge. Local conditions and local capacity of the governments is important in water management. You cannot take a solution from somewhere else and try implementing here in when locality is not prepared for that. So to address the current and future challenges, sustainability and resilience thinking in water infrastructure is key in urban policy making. Because if you don't have these both perspectives, things may not go in right direction. So we are stuck in a linear water use. What is linear? That we abstract water from groundwater or river, we treat, we transmit with bulk water pipelines, we distribute, and last lecture, Dr. Anuj has explained what are the challenges related to that. Then we use the water. Then there are sewage treatment plants which are working, not working, partially working, and we have a disposal. So all this, let's say, is a stuck in a linear way, that we are not putting back into the again use. That is a big challenge. Sewage treatment plants are there, but many of them are dysfunctional, not operational. Urban local bodies do not have adequate funds for operation and maintenance. Largely, we are getting capital investments, but operational maintenance funds are not generated by local bodies. We have long sewer networks, very difficult to maintain. I will show you some issues. So merely constructing an infrastructure will not solve the problem of water management or circularity. Ensuring the sustenance of the infrastructure is very important for service provisioning. Okay. So we have water policies internationally and nationally, that we have sustainable development goals. SDG 6 talks about clean water and sanitation. Then we have Mahua has various programs of providing and creating access for water and recycle water treatment, sewage treatment. So huge effort is going on from government side to do something about this issue. Still, the problem is very large. See, all these programs tries to achieve some circularity, some recycle water, but what are the challenges on ground? We will discuss. Okay, and there is a tremendous amount of money is also available. Only issue is how we can make use of that money in a systemic manner, in a holistic manner that I'm going to talk about. So let us first understand what's wrong with the current approach. If you understand this slide, most of my talk will be clear to you. See what is happening. This is our urban area, and this urban area may have some surrounding agriculture area, and you have water reservoirs. This may be groundwater, this may be lakes, this may be artificial dams or rivers. Historically, how we have developed, we have basically this freshwater abstraction from these resources, groundwater, surface water. So our agriculture areas, our household consumption, our industrial and commercial consumption, which may be city, outside the city, all are dependent on this fresh water. And in today's time, we are saying we are facing water crisis because these resources are depleting or getting contaminated. Now, we have to also think of a fertilizer story. Now, you will ask me why we need to talk of fertilizers in a water problem, and that is where the system connectedness thinking is important. Systemic thinking is very important. See, we are putting huge energy to fix nitrogen, and then we are applying these artificial fertilizers, which are highly subsidized. This industry, entire industry, subsidized to agriculture. Now that agriculture products comes to our homes as food. We have detergents, we have household chemicals, all that are coming to our houses, and expected that we collect them in a sewer network and treat it in a centralized wastewater treatment. Entire our practice is building large scale centralized sewage treatment plants. Now, what happens is this one centralized treatment plant is not working, the entire untreated sewage, contaminated sewage is going to contaminate our rivers, groundwater, and lakes. So this is what is happening historically. Now, to remove the nutrients, again, we have to put energy, which is again basically, and one time we are putting energy to fix nitrogen, and other time we are putting energy to take out the nitrogen, which is contaminating our water bodies. So see what kind of trap we are in the engineering trap it has created, because these two disciplines, chemical engineering and environmental engineering, are separately worked together, right? Separately worked. That these have invested in technology, developed technologies for remove the nitrogen. They have technology to fix the nitrogen. So issue is we have not holistically think how while developing what is happening wrong. So systematically we have to co-create some products of nutrient from composting for food waste, sludge, by creating a standards for that, so that we can check the quality of the sludge and then decide whether to apply for agriculture. We have to systematically create the local water, new water, for example, local water, so that we can keep the local water in the loop for a longer period of time, so that fresh water should be reduced. And nitrogen removal and energy generation is also possible. So I have seen sewage treatment plants which can be energy neutral also, that you generate energy from sludge and then you make that utilize energy for again operating the sewage treatment plant. So all that needs to change. This entire thinking has to change the way we are planning our water infrastructure. So this all is possible using decentralized systems. Okay. So centralized and decentralized, that debate I'm going to open today. Now, what I'm talking about is sustainability, and I'm not going to give any definition. You can apply these 5 parameters criteria. For example, what are the environmental impacts of the technologies and solutions you are choosing? What are their GHG emissions? Whether there are recycling opportunities? Whether the solutions proposed are economically affordable for all the communities? And operationally also economical, because you may have something capital fund which is funded by some agency, but our local body should able to operate that infrastructure. Social benefit, it has to be acceptable by the community, employment opportunities should be created, and equity should be achieved. Governance, state government, municipal governments, parasocial bodies should have a good governance for that, whether they can maintain that infrastructure, and it has to be technically easily replicable. Every time you should not have something very complicated, project design, and replication becomes problem. So sustainability in these 5 parameters, I'm going to judge whenever anybody says, okay, this is the sustainable solution. In today's time, resilience is very important. Now, resilience for infrastructure is where we have to understand that on x-axis your timeline. For example, one city started operating its water treatment plant for last 20 years or water systems. This is your original performance. That, for example, performance can be measured by water supply level, nodal pressure, sewage treatment percentage. So everything is going fine. And sometimes what happens is, let's say you're hit by a disturbance. For example, sudden urbanization might have occurred. Sometimes climate induced droughts are there or flood is there. What happens is our infrastructure service, which are defined by such parameters, so y-axis your performance, suddenly drops down. So how fast you fail, how fast your infrastructure fail is a indicator of robustness. Okay. So we have to think how robust systems we can create. Number one. Number two, how fast we can revive back. Let's say you are hit by a drought, you hit by a flood. How fast you can come back to original performance or minimum required performance. That at least some water you are trying to providing, at least some treatment is happening. So how fast you come back to the near original situation is defined by adaptability and flexibility. Okay, so entire future water sector will be assessed by these five sustainability parameters that I showed and this resilience graph. And while these failures you may think as these disturbances you may think is a challenge, I see them an opportunity. Because in conventional way, you may not get a chance to improve the performance. But as soon as some catastrophe struck, you have an opportunity to convince the administrators that now let us redo the things which we would have not done in a common situation. So you can take a transformational approach, such as you can think of a circular decentralized system to improve the performance than the original performance, and overall sustainability and resilience can be increased. So basically, this is the resilience theory for infrastructure. Now, why I'm saying this, in today's time, all engineers are trained to do a robust design. Everybody is okay, how robust your design is. We have been trained, our curriculums, our trainings have been about robust design. In today's time, our lab and our research is showing that there is a change in environment and there is objective changes after implementation. For example, you implement a water supply system with some 24 by 7 theory of design. But after implementation, you see that there is an intermittent water supply, or you implement for sewage treatment, but the situation is demanding you to do a recycling. So objective of the implementation is changing. You cannot know in future, in 10 years, 20 years, what are the rainfall patterns, what is the water quality. So your design has to be adaptable and flexible. So what I'm trying to say, these three parameters, how robust is your design, how adaptive is your design, and how flexible is your design is very important if you have to transform to sustainable and resilient infrastructure. Now, catch is that we have to do it in very smart manner. So basically, we have studied in this particular review of circular economy, and this paper I'm going to talk more in first part of the talk, that how we are stuck into this linear way, how we can put back into circular way by applying these 6 R's, which I'll talk more. Okay, so in the talk I'll share the presentation also. Everywhere we have given the references and we can read more. Now, circular economy is about shift is very essential for by applying reduce, reuse, recycle, reclaim, restore, and recover. Because our agricultural land, natural environment, water treatment plant, urban area, wastewater treatment, industries, water get exchanged between these, right? That you take the abstract the water, treat the water, use the water, industries use the water. So water quantity and quality get exchanged while moving in this particular system. So we have to think holistically how to manage this water cycle, which is urban water cycle. It is not natural water cycle. So there are 6 R's to achieve this. Reduce, that how much decrease in the consumption we can do. Now, this is very important for circular economy, because unless we don't work on reduction of water, all the efforts, how much water effort we are making are not sufficient for recycling. And reduce is very easy to implement, very low investment you are making, but I don't see many programs are focusing on reduce. Reuse is without treatment, how we can cascade the use, that you have taken a shower, but that whether can be used for gardening or some any other purposes. Recycle, use of treated wastewater within the same loop. That means In building, in a given zone, you're keeping the loop in this, keeping the water in the same loop. Reclaim, treatment of wastewater and its use outside the loop or process, that the city or a building is selling water to industries, or industries buying from the other uses. So where you are opening the loop, that is called reclaim. Recover, that you extract the valuable resources, sludge, nutrients, energy, that is the recovery part of the circular economy. And finally, restore, whatever excess you have, excess treated sewage, excess sludge, you try to restore to the nature. That is called restoration of the resources. So these 6 R's I'm going to talk more and how to achieve them. And this particular paper is very famous in the literature and in the policy making. So CPCB has taken this definitions and prepared these guidelines from this research paper. Whatever definitions I told, because when we started working on circular economy, there was no definitions. So we have come up with definitions to think in a systemic manner. Okay, we should not use reclaim, recycle, reuse loosely. There is a particular meaning, scientific meaning to these terms. Now, while we want to achieve these 6 R's, those cannot be achieved unless you follow some principles. So all the organizations have to follow systemic thinking, value optimization, innovation, collaboration, stewardship, and transparency. So unless these are also not, so you may have a very fantastic technology, and which can achieve very good recycling or reclamation, but unless organizations are not following this, the circular economy may not be enabled. So that is our one of the highlight of circular economy. So what are the challenges and opportunities in India? There are technological challenges. That there are some technologies which are in pilot scale. Technology selection is not correct. Conventional technologies are failing. Scaling up is an issue. Energy efficiency is an issue. Then there is economic consideration, that freshwater cost. See what is happening. We may have recycled water, but if our freshwater cost is not as competitive to recycle water, whatever effort you are putting, recycled water will not be used by the community. So we have to create a market for recycled water, which is currently missing. Non-revenue water we have to work on the reduction part. There are institutional and governance challenges. Our municipal thinking has to change. So social issues like lack of awareness, public acceptance, and infrastructural challenges that you implement and it start deteriorating. You implement the infrastructure, it start deteriorating. How we can upkeep the infrastructure? And there are opportunities also, that in some states, if sewage infrastructure is not there, they can think in a decentralized circular infrastructure rather than a conventional DPR, which takes sewage out of the city and again creates a problem for all. Okay, mixed land use and a benefit. People may think it is a problem, but I see as an opportunity, because you can exchange the water between different entities. That municipality can sell to the small industries or institutions or commercials. Resource recovery is possible, job creation is also possible, long-term economic benefits. So I see challenges in India, but a lot of opportunities also in water sector. So we have developed this framework of this reduce 6 R's and systemic thinking. And those who are interested for actually implementing can read this table. For example, collaborating between waste management authorities, market and consumers to design reclamation and recover facilities is very essential for achieving circular economy. So we have mapped these 6 R's with different principles of management. So then the second part of our work is measuring circular economy, because if you're not able to measure, you're not able to perceive the, let's say, municipal commissioner to work on circular. For example, you want to do weight loss. Unless you don't measure your weight at particular frequency, you will not able to know how much achievement is happening, and there will not be motivation. Same here, we have developed a tool called our water circularity indicator, which can be used to measure the water circularity. And that is basically from material circularity indicator, which is basically widely used for measuring circularity of materials. We have applied the same for defining water circularity indicator, where we have considered these 5 R's and basically develop the water circularity indicator. So what we did, we developed water circularity indicator and compare some other indicators are also there with them. I'll just explain. So it is basically used based on water balance. So water balance is that you have a stock. Stock is reservoirs, groundwater, surface water. centralized, decentralized, satellite treatment facilities, and there is a water consumption. So there is a fresh water coming in the city. There is untreated water going out of the city. There are NRW or some losses are happening. And there are recycled water, reclaimed water, and restored water. And there is a water reduction principles also you can apply. So water reused, water recycled, water reclaimed, all that you have to account. And how much replenishing of the stock is happening, that is also you have to account. So we have to create a system boundary for a given catchment and develop a water balance. And that will tell you the entire story of water circularity. So we use this framework and we mapped how much actual virgin water is taken from the stock and how much total water discharge to the stock. So entire water balance is created. We given some notations to this, all the terminologies, and we applied this thinking of material circularity, which I'm not going in details, but we mapped the use phase of water and disposal phase of the water. And this water circularity indicator is available. This tool is available, freely available, people can use. And we have shown why water circularity indicator is much more efficient than any other indicator in the past. So it's a very simple numerical value, captures 4 hours impacts. We can provide policy recommendations very easily. Currently, there was equal weightage given to all the hours, but the next part of the work was prioritization. That what I'm telling you is there are 5 to 6 hours you can apply, but for each city, you can tell whether to go for recycling first or reclamation first, because that will changes the local context. So in all these 6 R's, like reduce, reuse, recycle, if you tell me the city name and the local conditions, I will tell you which R should be applied first. For example, if you have a 40% NRW, you should first work on reduce rather than recycle, right? So that is what this prioritization framework tells you. So you have a hierarchy of, like waste management hierarchy, we have a hierarchy for circular economy. That first work on reduce, reuse, recycle, reclaim. But in some cities, there may be some large industry which may buy sewage directly. So without doing local recycling, you can have a tie-up with the industry. So that prioritization framework is also available. So this is second part of the theory of circular economy. So what are the real challenges in water circularity is, even if you produce the recycled quality sewage, there are standards are not, there are not comprehensive standards for pathogens are not there. Emerging contaminants is a huge problem because we are using cosmetics, pharmaceuticals in our households, household cleaners, other resources, nitrogen and phosphorus. How can we close the loop? And market, it's very important. You may have a fantastic technology, fantastic solution, but if you do not fix the price of water, no effort will be useful. Okay, so we have to think how we can create a market for recycled water, and policies and guidelines and push for the all the stakeholders is needed. So I already talked about measuring is the first step, and then some infrastructural changes and some practices of doing the engineering has to change, that I've talked now. So reduce. As I said, reduce is very important. This is the survey that we did in Mumbai, and you can see utensils washing is a 20 to 30%, clothes washing, flushing, and bathing. These are the main uses where a lot of opportunity in reducing the water consumption is there. Our study show that easily 20% reduction in water demand in many cities is possible if all these fixtures and practices are followed by the community, and cities should include in their DPRs so how much budget they will going to spend on reduction strategies. No DPR, no program is doing effort on reduction part of the system. Okay. For example, you may say I'm preaching, but what I'm doing at my home. So in IIT quarters where I live in campus here, I studied that my kitchen tap is giving 12 to 15 liter per minute. So I was worried. I'm giving lectures everywhere, and if this is the water flow at my home, what I can do? So I put these water aerators, and you can see 3 liter per minute. But this is not success, because as soon as I put our maid at home and my wife said this will not work, we will not live in this house. This is the real part of circular economy, that people's inconvenience will be there. So then they said, you do utensils, you do your work here, or you go back to this system. So this is the funny situation that I was stuck. And then I thought again, okay, what to do? So I removed this, again went back to this system for some time. Then I thought, when nobody was at home, I put 6 LPM aerator instead of 3 LPM aerator. Okay. And now, even in today's time, nobody knows in my home that this aerator is working. So what I achieved 50% water reduction in utensils washing, which is a huge part in our water consumption and which is very important for saving hundreds of MLD water, which is coming to our cities from hundreds of kilometers in some cities. Okay, so very simple things are very essential in circular economy, and circular economy problem cannot be solved just by technology and infrastructure. Please understand, every one of us has to work and solve this problem. So Nikita, my student, then develop a star rating, and in her thesis, 1 star, 2 star, and 3 star rating for water efficiency scenarios. And we have shown in Mumbai, easily 300 MLD can be saved if they go for this. They don't need desalination plant. They don't need new dams if they follow water reduction. But that motivation has to be there, right? So BMC's per capita average consumption is 200 LPCD, which has to be brought down. So those are interested. So a lot of focus we have given on reduction instead of jumping on recycling directly. As I said, this is very important. We are missing this, applying reduction as a principle. So now, if you have done enough effort on reduction, then you talk about recycling and reclaim. Okay. So how to achieve recycle and reclaim? That these are the overall management approaches. Prevention, conservation, as I said, which has to be displayed, work together in sync with the treatment, recycling, and recovery. And treatment, recycling, and recovery can be done at household level, on-site. This is called on-site, satellite, or building level. Decentralized, using some collection network, or centralized, which is current practice. What is happening right now? All of this other part are missing from the water management plan. Only sewer laying, treatment, that is happening, and that will not solve our problem for future. So there is a huge amount of technologies are available, right? There are tremendous amount of technologies available, and in this talk, I'm not going to talk about treatment technologies. So technology is not an issue here. So we have been trained about engineering treatment systems, but there are nature-based solutions also. Nature, phytoremediation, bioremediation, zoo remediation, hybrid systems. So we are not giving enough focus on natural treatment system. That is also missing in the current time. So what are the challenges in sewage treatment plants? Because you have to operate these technologies in sewage treatment plants. Operating mechanized treatment system is very difficult. Activated sludge process, SBR, MBR, these treatment processes require huge amount of energy, right? So operating these treatment systems is very difficult. There are sewage treatment plants, but sewage is not coming to those treatment plants. So we have an infrastructure and it's coming 10, 15, 20 years till 50% sewage is not received in the infrastructure. Our sewage treatment plants are dysfunctional. We have historically used nature-based solution. This is Karad from Maharashtra, where nature-based solution was there, and we have shifted to mechanized treatment system. And now, again, there is a new knowledge coming, which is not new. Indian traditional system, Indian knowledge system is huge. We have been a good practice of doing nature-based solutions, which is forgotten. So then there are building level efforts are also happening, right? People are doing something at building level, but operating building level STPs is very difficult. I see a lot of policies are coming that building level recycling should happening. I would say it is not recommended, because operating a building level STP or any STP is like maintaining a ICU patient. Please understand, because you have to monitor it regularly. You have to provide the required chemical dosing and all. You need a skilled operator. It's almost like a ICU patient you have to maintain. Which housing society will do that? Very rarely will find. So putting burden on buildings may not be always prudent. Okay, that is the point I'm trying to make. So we have studied the BMC's operational sewage treatment, sewage systems. Operating sewage systems is also a huge challenge. And BMC has a good setup they are managing, but many small municipalities and many municipalities are not able to maintain their sewage system. So these are the challenges. If you do not maintain proper systems, these are failing, and STPs are not, infrastructure is there, local conditions are not there. Like this STP, this particular city had lot of tabelas, lot of cow dung is expected to come. That is missed in the DPR, and you can see what is the consequence, right? So haphazard planning and design is another consequence. So there are practical challenges of centralized systems. That flat topography will lead to long and deep sewers, and I have seen sewer depths of 16 to 18 meters. How we can maintain? And then again, recycling back is impossible. Coming to small cities, you can see this is the DPR prepared by one of the consultant. And every on computer, it is very easy to lay sewer anywhere, right? Because you sit on a computer and lay a sewer line or a water pipeline because it's computer models are very easy to create. So what I see when I verify on ground, these are chicky forms. These are no habitations. So a lot of peripheral areas which may not need a sewer system right now are provided sewer network. So issues are excessive pumping proposed. They have proposed 7 pumping stations for such a small city instead of going for some level of decentralization. Sewer lines proposed in a very less population, low velocities, very low velocities. 60% sewers had low velocities, non-settling velocities not achieved. So we do a lot of stakeholder workshop to discuss these issues in IIT Bombay in various organizations. I have studied internationally also what is happening in Denmark, in Canada, in various places. What are the best practices? Where they are stuck? They are also discussing centralized versus decentralized. We conducted workshop in DTU Denmark. So this issue is global. What level of infrastructure? How to achieve circular economy? They are going for stormwater recycling plant. This is their rainwater recycling plant. They have resources. They are doing this. Whether we should go for such model, they are having purple pipe system. Purple pipe is meant for recycle water. So we have a plethora of treatment technologies, mechanized and nature-based solutions. Issue is there is a confusion among utilities which technology to choose for which city. And what I'm saying, it is not the technology, it is the configuration. How you plan your sewerage zone is more important than which technology you choose. So that is missing in the current context. So what are the sectoral insight from this recycle and reclaim? There's a lack of focus how that sewage conveyance will be operated and maintenance, how the sewage treatment plant will be operated. There is a lack of adequate consideration of the study area specificities while planning. Lack of studies quantifying the benefit of nature-based solutions. Only capital cost-based decision making is happening. There is no decision support provided for small and medium cities. Our manuals talks about only standardized solutions, but in locality, those solutions may not work. So what are the infrastructure challenges we need to do? As I said, we are stuck into highly centralized kind of scenario and or directly building level. But we can create a smaller zones of decentralized, scaled decentralized systems that I'm going to introduce. Because if you do very small systems, every engineering system have scale of economy. Okay. So as you can see, if you create smaller and smaller sewage treatment plants, your cost of implementation increases. So, and also too large systems do not provide you scale of economy. So you have to identify what is the operational scale for your system. And when you include the overall sanitation system, this is only STPs, this is with sewer network. Okay. So you have to see what is my scale of economy, including the conveyance cost also, because conveyance cost is around 70 to 80% in any city. Okay. So benefits of scale of economies are not attained for sewage treatment in small cities. Okay, you have to work to attain the benefit of scale of economies. And the advantage in cost reduction achieved in sewage conveyance is shadowed by scale of economy in treatment side for mechanized systems. Because what people think, I am doing a large sewage treatment plant, mechanized treatment plants, that means better. No, because you are losing on your convenience scale of economy. Okay, so a lot of work we have done on this. So what I'm trying to say is your sewage treatment is only 20 to 30% of the project cost. Your convenience cost is 60 to 70%. So unless you don't innovate on this part, sustainability, resilience, or circular economy will not achieve. So the scale is more important of infrastructure than actual technology. So right now there is a comfort zone among practitioners, consultants, who prepare the DPRs or the bureaucracy, because one DPR gives you the entire infrastructure in one go. which may be convenient right now, but which is not good for long term. Alternatively, buildings are doing something at highly decentralized, localized treatment that is also not sustainable. So hypothesis of is that optimal scale from holistic perspective lies somewhere in between. So when you apply these 5 parameters of sustainability for highly decentralized and highly centralized systems, so life cycle costs, social benefits, potential for recycling water, resource recovery, ease of governance. All these parameters show that, and environmental impacts show that sustainability is better at some optimal scale of operation rather than extremes, operating in extremes. Similarly, robustness, adaptive capacity, and flexibility is better for decentralized systems. And again, two small systems do not give you infinite resilience. Resilience will stop at some level. So what I'm trying to say is, for every city, you have to identify ideal zone for achieving sustainability and resilience. Now, your question may be, where is that ideal zone? So from based on our understanding, if your city is generating about 10 MLD, you can start 1 to 2 MLD zones. Ask your consultant to prepare smaller zones. Do not create a huge centralized infrastructure. 100 MLD city, 5 to 10 MLD. And then you have 500 MLD, 25 to 30, 2000 MLD, 50 to 80 MLD. So that scale we have given, which may change a little bit here and there, but this is the starting scale that we have proposed. Okay. For example, in Pune city, if you study, as per our analysis, 60 to 70 MLD they should go for. Right now, they have highly centralized sewage treatment plants or highly decentralized. Similarly, in Mumbai, you can say our scale is 80 to 100 MLD. Mumbai is planning 600 to 500 MLD, which is not prudent. That is the analysis showing. Okay. Or they are doing very small scale, which is also not good. So this scale, we introduce you the concept of scale decentralization. People use the decentralized as a term, but right now I'm telling you, scale decentralization is a another term which is doing things at scale of economy. So this is our research, which is now internationally recognized. And this is video, this Shweta and Parmeshwari has created very nice video that you can watch later to explain this scale decentralized concept. Now, this concept is again how to apply for actual sewer network, that also is available. This work is taken internationally. Now in China, people are using this concept, but I don't know when India will follow this scale decentralization. This is a letter from a practitioner in US that whatever we have done is they appreciated. This concept is very useful even in US context. So what I'm trying to say is, if you just lay a very large trunk main, what happens is you have a problem of maintenance, and people may have to enter, which is banned by the law, but still you see this news happening that people have to enter because you're not able to manage the sewers. So we have to stop at some depth of excavation for sewers. Why I'm saying is because recycling back is very difficult. If you have a highly centralized one locations, very difficult. So redistribution of water is difficult. You can do small scale, decentralized, multi-story STPs also you can do to if there is space constraint. So point is we have to identify the co-benefits of decentralized systems. Only based on cost, you may not able to prove. So what you have a choice of decentralized systems, and you may go for mechanized systems. You are in a city like Mumbai, you may go for mechanized systems. And if you're in a city, class one city, small cities, you can go for nature-based solutions. Now, natural treatment system is a neglected part of the chain. Okay, there are a lot of technology providers for nature-based for mechanized treatment systems, but natural treatment systems such as phytoremediation, bioremediation, zoo remediation, hybrid systems are missing from the practice. Large practice missing. For example, this is one of my colleague and who has done this in Himachal, Dr. Dinesh Kumar, who has implemented these nature-based solutions in many places. So this is just coming up. So what are the benefits in urban? That it can be used as a tertiary treatment. In peri-urban, it can be used as a full-place treatment systems in peri-urban and rural. So huge amount of opportunities for future planning of infrastructure is possible. And the cost economics you have to think, because mechanized systems although requires less land, but those are very energy intensive. Mechanized systems like SBR, MBR, active slash process, MBBR, any mechanized systems are costly in terms of 30 years of operation. Please understand. Land requirement is very high for nature-based solution, but operational costs are very minimal because there is no energy required. So what we can do, we can couple mechanized treatment and nature-based solutions, and this is called hybrid treatment system. So what I'm trying to say is, if this is your outlier BOD standard on x-axis, and this is operation and maintenance cost, you can see mechanized treatments exponentially increase the treatment cost as your recycling standards is increased. Whereas nature-based solutions, your operation and maintenance cost is highly stable. But land requirement for nature-based solutions is very high, but for mechanized treatment system, land requirement is low. So what we can do, we can shift from mechanized to nature-based solutions to optimize the land use at 30 to 40 milligram per liter. And this analysis shows that if you account for 30 years of life cycle cost, 30 years life cycle cost means the current capital cost and electricity cost for next 30 years, even in urban areas, even at a market rate, if municipality buys the land, they can, the life cycle cost is much cheaper than mechanized system, but that thinking is not available. In the economic evaluation of the treatment technologies, operation and maintenance cost plays a significant role, okay, which is currently neglected. So this analysis shows that in any setting, it is wise to invest in land, and that policy change is needed, that municipality should be allowed to purchase land for sewage treatment at a market rate and do the nature-based solutions, which is very radical thought I'm telling you, but that is essential if you at all want to sustain something for long term. For example, this is again Dr. Dinesh work where hybrid treatment system is implemented. Part of the treatment is mechanized and part of the treatment is nature-based solution to optimize the land use. Okay, so that is the hybrid treatment system concept. So then what we have done, because many people are asking what are the actual benefits of natural treatment systems and phase-wise implementation. Because right now all the DPRs are prepared in one go, which is not working out. Please, we have to consider this. So we first at national level, we analyzed if we do a phase-wise planning, like 10 years DPR for 10 years and nature-based solution integration or hybrid treatment system integration, what is the cost saving and what is the GHG emissions, considering the land rates in India. Okay, so this is Shweta's work, who has done this fantastic work where nationally she has estimated what is the sewage generation going to happen up to 2051. And if we do the phase-wise planning for rural and urban, and if we do the sewage treatment deficit, and if you apply different scenarios, what are the cost savings? For example, what are the scenarios? Conventionally, you will go for mechanized centralized system in single phase. That is base scenario one. But if you do one multi-phase, that three-phase planning, integration of nature-based solutions, applying life cycle cost, such as all the costs are accounted in today's time, and you apply different in rural, you let's say 60% nature-based solutions, in urban let's say only 10%. I'm not saying in urban everything can be done in nature-based solutions. Okay, even with that, if you see the benefits, and this is the estimated sewage generation gap in different states, Uttar Pradesh, Maharashtra, Tamil Nadu. So this estimation we have done, what is the estimated sewage generation in 2051, and you can see these two scenarios. If as soon as you go for a nature-based solution and phase-wise planning, you can get huge amount of trillions of Indian rupees can be saved if you go for phase-wise planning, number one. And these nature-based solutions can provide you savings in the GHG emissions, greenhouse gas emission, because you're mitigating the climate change also. So tremendous amount of co-benefits are available in this system as well. So monetizing greenhouse gas, and again putting this for sewage treatment is a solution to achieve circular economy in cities. So what I'm trying to say is you have to see what is the prevailing land rate in the city and then choose a treatment system, whether to go for a fully mechanized system or whether to go for fully nature-based solution or hybrid treatment system. So our analysis shows that at a particular rate, about 5 to 6 crore per acre rate, then only fully mechanized system should be adopted. Okay. So purchasing land for treatment is for using nature-based solution is essential thinking in current time. So this research is also available. Those who are interested researchers can follow this work. Now, finally, creating the whatever you are doing, unless you do not create the market for recycle. For example, we have to work with different stakeholders, industrial clusters, commercial establishments, railways, metro boards, port trust, construction sector, premium consumers. To push, you may apply a circular infrastructure, but if there is no market changes happen, all these efforts will be fail. Okay, so both the governance, the economic side, the policy side, and the infrastructure side all has to change simultaneously to achieve circular economy. So finally, the recovery is a futuristic that we can also recover the resources. We can use the water for toilet flushing, gardening, reclaim, agriculture demand, and entire water economy we can develop if we integrate nature-based solutions. That is the point I'm trying to make. And restore is excess water. For example, if many townships are sometimes are generating excess treated water that can be recharged into create the recharge zones and can be recharged. So finally, for identifying what is the circular solution, people will ask what criteria I should use. So we have developed a multi-criteria decision-making tool which considers the technical constraints such as land requirement, technology performance, circularity indicators, economic indicators like capital cost, operation maintenance cost, life cycle cost, social indicators such as acceptability, how much use of unskilled labor, manpower. So, see, in India, we have to think for all aspects. What works in Europe or a developed country will not work here. We have to consider what are the environmental points that this solution will give, and resilience thinking. It's a long term. If you have to really think in a long term manner, we have to consider all these parameters. And for that, we have developed a Jal Vishwa, which is a outcome of DST funded project. Jal Vishwa is an open source tool. Anybody can start using immediately. It's free tool for everyone for research practice. Where first tab is life cycle costing. That this Jal Vishwa tool will allow you to do life cycle costing. If you just use life cycle cost for decision making, you can use this tab, or you can use multi-criteria tool also. So those who are interested can use just type Jal Vishwa in Google and you'll start using this. And there are tutorials also available, and we can provide the training also. And we have presented it in Denmark, in Irma, many places we are training this Jal Vishwa. So life cycle costing, we will ask you some data and it will generate a report that what is the life cycle cost. For technology selection, there are economic, as I said, many indicators can be used. You can add your own indicators depending on the case, and it is operated from our side, so it is completely neutral. You can use for tendering and bidding. This that is the purpose this tool was developed. So this is the technology selection tool. So in summary, we have to consider simultaneously sustainability and resilience in decision making if we have to transform to circular and sustainable systems. So implementing appropriately scaled decentralized systems is very important. Blindly doing recycling or reclaim may not be prudent. You have to see what is your condition of cities in practices, infrastructure, then prioritize this circular economy. Measuring water circularity is very essential. Using life cycle costing is very essential. Purchasing land for treatment, doing phase-wise planning, mixed sewage treatment approaches, and finally multi-criteria decision making. Unless we don't do this, I don't think we will be able to transform to urban circular urban water. Thank you. I'll be happy to take questions now.
Thank you very much, Professor Pradeep Kalbar, sir. On behalf of Maneesh, sir, I will be hosting the Q&A part of this session. So we will be taking up the questions one by one. First, we are having a question posted by Dr. Sakti Vail. Sir, are you comfortable if you want to directly ask the question by unmuting yourself, or should I read your question?
I'm also available here.
Okay, sir.
So could I will start now. Thank you, Professor. Good to see the research work on the urban water. I have 2-3 questions.
Sure.
Number one, how this indicator actually be applied for the water security of urban and peri-urban areas. That's number one. Number two, how the indicator is quantifying the rainwater harvesting measures. For example, rooftop, source control, site control, regional control measures of sustainable urban development solutions, and groundwater recharge initiatives are urban areas. These are all two questions on specifically on fresh water.
Mm-hmm. So basically, the circular indicator, if you see in the water balance, I showed one arrow of reduce. So how much water you are reducing by recharging this sites? So there is a stock for every city, every catchment. There is a stock of water that you have to first quantify. Once you know what is the stock, whatever interventions you are using for reduction, for example, rainwater harvesting or green roofs, that much quantity you can deduct from the stock. So it is basically water balance based approach. So that whatever interventions you are making, you have to start measuring the effect of that, and that in that paper we have the Excel tool available that I can share with you also. That in that you have to add what is the reduction happening in your city.
Okay, thank you so much. The other one mainly on the sewerage issues.
Yeah.
As I said, decentralization. Yes, we are all very happy that if you go with the decentralization approach now, but in our whole cities, getting the land parcels are the greatest challenge.
Yeah. So, in my experience, what I've seen in many cities, they're pumping the sewage to make it centralized. It's not that by gravity is flowing. In many cities, pumping is used to make it centralized, which is a currently practice in many cities. So, what we can do at that pumping station, we can create some land. You can go for a multi-story STPs also. In today's time, multi-story STP concept is emerging very large. So, you have to see for your city what is the scale, how much is the land price. And as I said, you have to think of 30 years of investment, 30 years of operational cost. And if that cost is accounted right now, and you can at a market rate, at least 2 to 3 acres per 2 to 3 crores per acre is easily compensatable if you consider life cycle cost. That thinking is not there right now. We just think, okay, there is not land parcel. For many infrastructure projects, people are buying land, municipalities are buying land, not for sewage treatment, because that is not given as a priority in the entire decision making. So my point I'm trying to make is you can go for decentralized, multi-story, scaled zones of sewerage, which will give you a long-term resilience for water.
Again, I would slightly differ. I have been working on various projects in the preparation of detailed project reports for the underground sewerage schemes. The current project which I'm working in Chennai peri-urban area called Tambaram City Municipal Corporation, wherein people are even not even allowing us to build even a small lift station which are below the road. That is the scenario. Lift stations.
Yeah.
Okay, number one. Number two, land availability is become a biggest challenge for us. Wherever the land is available, in spite of following up the natural flow direction or the natural contours, we may even have to forcibly take even the negative slope also in terms of towards the land availability side.
Yeah.
That again, once again, the challenges are so much. That's what we are even struggling it in the in concluding and putting out the construction of the entire sewerage system. That is one thing. See, when we talk about nature-based solutions, yes, I agree. The land is again an issue. Urbanization is very much happening, and again, the main constraints with the NBS approach, will they be able to treat the sewage of more than 1 MLT capacity in urban areas? That's the greatest challenge. That is one thing. In the sewerage collection system also, when you said that about 60% of the areas are also not conforming to minimum flow velocity or minimum self-cleaning velocity, yes, that is also happening. So if you want to go below minimum in achieving this self-cleaning velocity, we'll have to go even deeper, since most of our cities are having very flat terrain. Number one, the constraint. Number second constraint is, when we design the entire sewerage system, it is for ultimate year. Right now, you don't get ultimate flow, as everybody knows. And all our guidelines, especially in Tamil Nadu, the minimum sewerage, the collection system diameter, we have to start from 200 mm, even in the starting node itself. So how can we achieve it? That almost 60-70% we are not getting it. So what is there when it reaches the ultimate, the flow actually flows. Till that time, we need to have a very frequent flushing of it.
All these technical point, all these technical points, yeah, I'm getting your technical points. The issue is unless that transformative thinking, as engineers, we don't come into bureaucracy and politicians, things will not change. Else you will be forced to do the DPR as per their wish, And that's why I'm saying that only talking, okay, we'll achieve something different, will not happen unless our practice of engineering will not change.
So is there any alternative solution? That's what I'm asking
So,
for it.
so these are the alternatives, but these are, you're comparing them from what bureaucracy or politicians wants us to do, and that will not happen. And that's why we have to form a very large group of professionals to convince them in long term this is not going to work out. You may lay a sewer, and that's exactly happened. I will not name the city. Most city which has received the award for water has negative slopes in sewers, and sewers are opened after few years because sewage is not convinced, the pumping station is not operational. So do we want that situation? That is what right now we
Then
are.
the entire manual has to be changed.
And that's where we have to talk to CPHU cumulatively to bring the changes, required changes. Only one or two persons, if we keep isolatedly talking, this will not happen.
No, I agree. See, I'm really actually, as a fellow citizen, I'm really in a very big, mess. Actually, the whole India. Number
Sir,
one,
I'll tell you, when I talk to CPHU, they say we are not getting representation, that what's not working out. So please make a representation to CPHU. Whatever problem in water supply or sewerage manual we are facing, formal representation from water supply boards, sewerage boards, municipalities is not happening.
no, the issue is when we go and apprise for funding with CPHO, they are insisting to follow their own manually. They are even not even allowing that.
That's what, sir, we have to go as a group and not for funding, just for when you don't go for DPR, without DPR, you go that we are not in general are not happy with the guidelines that we have to do. And I have tried that. I have tried that when CPHU manual was prepared for water supply. I just raised so many questions. Me and I think Sandeepan is also there in this group. We have raised many questions, but we have been told that no city has representing these kind of issues, and these are your own understanding. That's what we have been given.
No, again, I see we have been representing it. Number one. Number two, as far as the NMCG, all other initiatives are concerned, the whole task of cleaning the entire Ganga was vested with the group of IITs. You have been the technology provider or the master system advisor. So all the roles have been provided for more than 10 years. So where is the transformation happen from the IIT
Dr.
sector?
Saktivel, there is a disagreement between academia also. The way I am giving the talk, the other IIT professor will give the talk in a different manner. So there is a disagreement. Please understand, there is a disagreement between academia also. It's not that it's only we all are agree. I disagree with many of my colleagues, right? And they can disagree with me. So it is so open forums are missing in this particular topics of water supply and sewerage. Oh, no open. Why I agreed to this talk? Because I know these questions I'm going to face. And last week I hosted a workshop on water supply, open discussion, not like some conferences in five-star hotel where you go and just talk of great things. We don't do that. And such many open forums and their documentation and representation has to happen. It is not, as you said, if I go to CPHU, they will say that other 10 professors in IIT saying opposite, that we should go for centralization. I'm basically my meeting ends there only. Please understand, okay?
So this is anyway. We'll work together
Sure,
in
sir.
in bringing the change on the
Exactly. So
on
my
this
point is, those who are think that whatever changes required in water supply manual and sewerage manual, we should work together and represent for positivity in our country. That is my intention. Okay, and that neutral group is very essential. Whether you will what with solution and what guidelines we should want, there should. I point is there is no enough discussion happening right now. Open discussion. That's my point.
So let us jointly work and create
Sure.
this change.
Sure.
Let us be the change what we want.
Yes. Yes.
Thank you so
Exactly.
much.
Okay, now we are having our second question from Mr. Khileri. If we develop renewable energy and use it for mechanized treatment, then GHG emission factor can be lower. Please throw some light on it, sir.
See, in nature-based solution, you mitigate the carbon dioxide is fixed, right, by the plants, because in nature-based solutions you use plants, constructed wetlands, you use the plants, and those plants fix the carbon dioxide. So alongside the treatment, you are also fixing the carbon dioxide. Number one. Number two, electricity is also not required for large operation of aeration or mixing, all that kind of thing. So basically, you're saying we're saving electricity, and basically you are fixing the carbon, which gives you the GHG emission reduction that can be monetized. That is the advantage of nature-based solutions for climate mitigation.
Uh, Okay, another question we are having from Mr. Prabhat. He has written that given that sewage conveyance accounts for nearly 70% of system cost and long-term sustainability depends on life cycle performance, how should cities determine the optimal scale and zoning of treatment systems rather than defaulting to centralized or building level approaches?
Starting thumb rules I given. See, for any city to determine the optimal zone is based on the scale theory, scale of economy theory that I presented. Number one. Number two, there will be physical barriers such as railway line crossings, river crossings, nala crossings, which people usually try to cross by putting a lot of infrastructure, which can be locally segregated and treated separately. So the scale of operation, if you, I'll share the slides, and again, I think video will be also shared. If you see that the scale slide for 10 MLD city, I'm saying 1 to 2 MLD zones. For 100 MLD, we are saying 5 to 10 MLD zones. So these starting thumb rules we have given to achieve, because right now there is no guideline available that what kind of scale decentralized zone should be there. Again, this is proposal from my side. There may be agreement, disagreement. That's why I will not enforce this, but I would say these are the starting points. And as Dr. Saktival is saying, there is a group needed to work on to identify what is the optimal zone. For metro cities, it will be different. For million plus cities, it will be different. For class one cities, it will be different. For medium cities, it will be different. Okay. So it is not a straightforward and one answer available, but you apply this thinking of zoning and then prepare your designs.
Okay, sir. Again, we have having another question from Mr. Viresh. Sir, if we use microbial fuel cell technology in any of these, is it feasible or not?
See, MFC technology emerging, and I don't know what is the scale of economy right now in this technologies. But as I said, technology is not issue. This all solutions are technology agnostics. You give me a technology, if it is working, I'll put it at a appropriate scale. Okay, and if MFC is going to give me energy to operate it at optimal scale, my guess will be it should be about 3 to 5 MLD plant you need to generate enough energy so that other infrastructure supporting electricity generation infrastructure can be put in. So it's not only per se technology discussion is not needed. It is how much size, what is the current readiness level of that technology is essential to understand.
Okay, sir. Another, we are having one comment from Mr. Supratim Roy. He has written that, firstly, many thanks for this very informative session. A lot has been learned from this. Also, the proposal for scaled decentralization is the need of the hour. Kudos to the researchers for such a work. However, in our country, we have to think all the aspects before implementing anything, as it was mentioned in the end. Many STPs are not designed properly to mitigate the issues. There is also the issue of land acquisition, etc., in many places. Once again, thank you very much for this session. Looking forward to gather knowledge in the further sessions.
It's just mostly generic, and as I said, many issues are there. Definitely, we have given the large principles of change of thoughts, and you have to consider the local conditions and practice.
Okay, sir. Another question we are having from Mr. Khileri. Do you think that since the engineering matters are decided by bureaucracy, less competent people, and this is the major cause of the non-implementation of the best practices in India, what is the established practices in other countries like European and Nordics, etc.?
Yeah, very good question. Definitely, the our governance has to change. Number one, I'll give an example of Denmark, where me and my student have done a lot of field work studying their governance model. See, their municipality doesn't have the role of maintaining the water and sewerage infrastructure. They have a new entity called utility. Utility means it's a private, but it's a non for profit. Okay, and that utility is basically trained and capable, very capable people. PhD holders are there to operate and design plan. So in-house design, in-house planning happens. See what happens in our country. We get a multilateral agency funding. They come up with their own approaches. So entire centralization thinking of in this water supply sewerage system is because we are getting funding for some funding agency. They are dictating their norms, their guidelines. Actually, water and land, as per our constitution, is local issue, right? It is in the so our local body should manage their water and land as per their preferences, as per their choices. But because the funding is attached to some by some agency, our local bodies are not able to take their own decisions. Very few means, for example, all our innovations like what Dr. Anuj presented in last lecture, shaft. If you see, we have able to implement immediately in small cities or rural areas because their decision and their funding is in their hand for that particular innovation. If I put it into to standard DPR, they will ask where it is in CPHE manual, where it is in this guideline or that guideline. Those questions are asked because funding is linked to these guidelines, and which has to be challenged by all of us as a fraternity of these professionals of water and sewerage sector. It's a very big issue of what practice we are used to, what governance model we are following. Definitely, we cannot suddenly shift to Denmark kind of model, but some freedom to local municipality has to be given how they want to manage their water resources in what manner. Okay, so very big change in many sectors we have to do.
Okay, sir. Another comment we are having from Dr. SM Yadav. He has written that what they have done for highway designs, we need to do for sewers and water supply or storm water. Design based on the individual city requirements beyond CPHEEO.
Yes, and that's what exactly to do that, we need our own strong, it's like some association which can actively challenge bring the local issues and challenge what is not working out. Only me saying alone, as I said, academically, somebody else will say something else. One practitioner or something, another practitioner will say something else. That has to stop, and collectively we have to come up with our own understanding about these issues.
Okay, sir. Another comment we are having from Mr. Khileri. He has written, please give some reference to some materials like books, journals in the field of water, WTP, STP, which we can refer to understand the subject matter in better way and work towards sustainability.
I will share. I will share in the group the papers and link. And in my presentations also, all the links were given. But if anyone specifically want, I'm in the group, so I will provide more. Sure.
Okay, sir. I think that's all we are having for today.
Rana sir has some question. He has raised the hand.
Yeah, very good
Okay, sir.
afternoon, Dr. Pradeep. First
Yes.
of all, thank you very much for an insightful presentation, and which you have given like a very comprehensive framework how to implement the circularity and which is needed our also. So during the presentation, you mentioned about that for the technical perspective, there are three important parameters. One is that design should be robust, and second thing you mentioned about that it should be adaptable, and third flexible. So can you give an example? Because we design as per the CPHO manual. So
Yeah.
how to enable the adaptability and flexibility in the design component? That I want to understand the concept. Some example if you can refer.
For example, flexibility means that right now we are building, let's say, a sewage treatment plant for let's say for a city.
Mhm.
Right now we are taking horizon of 30 years. Okay, no problem in taking horizon of 30 years or 50 years.
Right.
You can allocate the land for 30-50 years, but plan the modules of implementation in a phase-wise manner. Okay, so that if any change in the effluent happens, so that you can immediately next module can take up the change. Okay, that is the adaptability or sense. So that thinking is right now missing into preparing the DPR. What is the excitement in the DPR? That in one go, I'll build a DPR, the sewage treatment plant, which is very large. Because funding is associated, funding is available, contractor is available, and city wants to celebrate that they want to go for they want to complete the target of having a sewage treatment plant. And as I said, I will not take name of the cities. Very, very big cities, their sewage treatment plants are running dry. Sewage is not reaching to them. So what is the point of having such a one go design? Instead of that, modular design is a way for achieving the flexibility and adaptability. So modular design is a very well practice in many other, let's say, for example, if you study the private townships such as Gift City, Palawa City, they don't spend money like municipalities. They will go for zonal treatment systems, zone wise.
Right.
One cluster is developed, only that sewage treatment plant, local recycling, because they know that the value of money. So a lot of to be learned for our municipal DPRs from this private township, and that needs to be conveyed in our guidelines. That need to be conveyed in our practice.
Okay, got it. And sir, in the last presentation, you have given like a glimpse of Jal Viswa toolkit. So if it would be good that if you could share the link where we can get it, and maybe that one session can be organized, demo session, demonstrate how it works. Those that will benefit for the reader.
I suggest my student's name, Dr. Shweta. She can organize the training. I'll suggest to Dr. Maneesh. Sure.
Thank you very much. Thank you very much, sir.
Thank you.
Thank you very much, sir. Pradeep Kalbar, sir, for giving your valuable time for this presentation today and the wonderful lecture. I think we have taken up all the questions in the chat sections and still not getting any raised hand to discuss something. So I think we should wind up the session now.
Sure.
Thank you very much again on behalf of the entire group, Hydrology and Climate Change. We look forward to further discussions like these topics again and again, and helping people to pursue these kind of studies and guiding the society. Thank you very much.
Thank you for hosting. It was very nice to interact also. Thank you.
Thank you very much, sir. Thank you.